Hello there, good day. Welcome to my summer coaching class. Now, in my summer coaching class, I take different classes on topics that they expect to see in the next class. So it means that you were in JS2 and you're about to enter JS3, or you've been promoted to JS3. You've been promoted to JS3. So the way the summer coaching is designed is to help you learn at your own pace, meaning that you can pause, you can rewind, you can fast forward this video to understand better. And there will also be a one-on-one time with me where I would answer questions, any questions you have related to this topic, maybe from my teaching or based on what you studied on your own. Now, the topic for GS3, the first topic I'm looking at is number base. Now, number base is a counting system. When we talk about number base, we are talking about ways of counting. And the two most common base that we know is base 2 and base 10. Binary numbers, and denary numbers. Now, I will need you to pay attention to this. Why should you pay attention to this? This is one of those topics that you probably were not taught in basic 5, basic 6, but you learned in junior secondary school 2, that's JS2. There are certain topics that are brought over from primary school. In junior secondary school, you just advance. You just learn it or learn about the topics with much more furtherance, meaning that you just go into it deeply. But when it comes to number base, you actually begin in JS2 or maybe JS1. You begin in JS1. You begin in JS1, I think JS2. You begin in JS2, then JS3. So number base, we're talking about a counting system. And we have two bases that are common. The other base, there's base 2, there's base 3, base 4, base 5, base 6, base 7, base 8, base 9. Then the one that is common, base 10, denary numbers. When you hear the word D, it's talking about 10, decimal 10 divided by 10, decimal divided by 10, binary, bisimals divided by 2, decimals divided by 2. Or let me use this example. Bicycle, it has 2 wheels. Bicycle, 2 wheels. Bicycle, 2 wheels. Decagon, 10 sides. 10 sides. So now let's continue. What do you need to know about binary numbers? There are two numbers in base 2. They are 0 and 1. There are two numbers in base 2. They are 0 and 1. While there are 10 numbers in base 10. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this lesson, this is the focus of this lesson. You're going to learn about binary numbers, denary numbers. You're going to learn the differences between them and how to convert from binary numbers to denary numbers, and how to convert from denary numbers to binary numbers. Or simply put, how to convert from base 2 to base 10, and how to convert from base 10 to base 2. So that's what we'll be looking at in this lesson. Now, the reason why number base is important is in our counting system, we actually count in 10. If you've not paid attention to it, let me show you this. We count in 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We count in this base 10. 9. You see, after 9, we have 10. Then after 10, we will go to 10 plus 1, which is what? 11. 11 is actually 10 plus 1. So we are counting in 10. We are counting in 10, meaning we are grouping in 10. Imagine a dozen. A dozen is actually counting in 12s. 1 dozen, you have 12. 2 dozen, you have another 12. 3 dozen, you have another 12. 4 dozen, you have another 12. So that's a counting system, a way of counting. But this our calculation. The calculation we do in mathematics is actually counting in 10. We are counting in 10. Our base, the most common base, the natural base we use in solving problems in mathematics is actually base 10. You might not know about it, but now you know. We actually use base 10. 12 is the product of 10 plus 2. 20 is the product of 10 plus 10. You can go to 21. 21 is the product of 20 plus 1. Can you see? Can you see that? And 20 is the product of 10 plus 10. So we can say 21 is the product of 10 plus 10 plus 1. Summation of 10 plus 10 plus 1. Are you seeing it? So we're actually counting in 10. In tens. So base 2 will be counting in 2s. Just like in time past, Roman numerals is counting in 5s. 1, 2, 3, 4. When it's 5, they count again 1, 2, 3, 4, 5. These are the right 10 in Roman numerals. This 10, they are counting in what? 5. And the importance of this is that binary numbers is very, very important. Base 10 counting, so base 10 is base 10 and base 2 is very, very important because all our calculation is done in base 10. And base 2 is so important because computer programming language, computers actually use binary numbers. 0 for this, 1 for the other. 0 for this, 1 for the other. So the programming language that you see in computer, it operates on binary numbers 0 and 1. 0 and what? 1. So let's dive into it. I'm sure you have written this, or you can rewind to write it. Now look at this. 2 in base 10, or you can write that is 2 in base what? 10. This is how I write it. Will I write 2 in base 10 or 2 in base 10? The 10 in numerals, the 10 in what? Words. If you just have a number 2, there's no base, we assume that it's in base 10 because base 10 is the most common base used in mathematics. The most common base used in what? Mathematics. So if you want to write in base 2, 1 in base 2, we can write that it's a 1 in base what? 2. Are you following me? 1 in base 2 or 1 in base what? 2. How do we move from base 10 to base 2? It's very, very what? Simple. Before doing that, we must learn how to express numbers in base 10. We must know how to express numbers in base 10 or express numbers in base 2. Now, if you have this number in base 2, 1, 1, 0, 1. Now, because in the base 2, we're not going to call it 1,101 in base 2. No, we can't call it that because 1,000 is actually greater than 2. And remember we said that in base 2 there are two numbers, 0 and 1. So 1,000 is greater than what? 2. 1,000 is actually 10 in 10 places. Hence is in base 10. 10 in 10 places. Are you saying that? So 10 in 10 places. So how do we express this number in base 2? How do we expand it? That's the expression. How do we expand it? To expand this number, this is how we do it. To expand it in this base, you say this is 0, 1, 2, 3. Are you saying 0, 1, 2, 3? So to expand or express it in this base, you have 1 times. How did I get 0, 1, 2, 3? We number this number from 0. We're going to number it from 0. 0, 1, 2, 3. 0, 1, 2, 3. So you have 1 times 2 raised to power this 3 here, plus 1 times this base 2 raised to power this 2, plus 0 times this base 2 raised to power 1, plus 1 times this base 2 raised to power 0. So we've expanded this in this base. We've expanded this. We've expanded what? This. We've expanded this. Have you seen how we've expanded this? Let's take another example. Let's expand this in this base. To expand this in base, or to express it in this base. How do we do that? To express it in this base, you will have 1 times this base 2 raised to power. Before that, let's number the 0, 1, 2, 3, 4. 1 times 2 raised to power 4 plus 0 times 2 raised to power 3. Where did I get is 0? 0 here. 0 times 2 raised to power 0 times 2 raised to power 3. 0. The next one plus this 0 times this 2 raised to power 2 plus this 1 times the base 2 raised to power 1 plus 0 times 2 raised to power what? 0. So these have to expand this. Did you get that? You can rewatch to get that better. So what we need to learn after this is how to convert a number in base 2 to base 10. It's very, very simple. It involves this process. I'm going to show you. This, what we have done here is to expand in his base, expand in the power of his base, expand in his base. That's what we did here, to express this in the power of his base, or to expand in this his base. So how do we then convert from base 2 to base 10? Convert from base 2 to base 10. Convert from base 2, which is binary numbers, to a ternary numbers. Because every number can be converted to another number in a different base. How do we convert numbers from base 2 to base 10? The first thing we do is we expand the number. Let's say you have 1 0 in base 2. You are asked to convert it to a number in base 10. The first thing you do, you expand this number in base 2. You express in the power of this base. So you say 1 times, don't forget 0, 1. 1 times 2. You number it. This first is 0, this is 1. 1 times 2 raised to power 1 plus 0 times 2 raised to power 0. So having done this, we're going to add. We add the total of this and this. So 1 times 2 raised to power 1 is 2 plus 0 times 2 raised to power 0 is 1. Take note that 2 raised to power 0 is 1. 1 raised to power 0 is 1. Any number raised to power 0 is 1. Apart from 0, 0 raised to power 0 is not 1. So any non-zero number raised to power 0 is what? 1. So let's get back to this. So from here, 1 times 2 is 2. 0 times 1 is what? 0. So you have 2. It means that 1 0 in base 2 is 2 in base 10. 1 0 in base 2 is 2 in base 10. Now let's take another example. Let me quickly write another example. Let me add more numbers. So if you have 1 0 1 1 in base 2, you want to convert to a number in base 10. Same thing you do. You number it 0 1 2 3. And after you've numbered it, you say 1 times 2 raised to power 3. 1 times 2 raised to power this 3. Plus, what's the next digit? 0 times the base. 0 times base 2 raised to power 2. Plus 1 times the base. 1 times 2 raised to power 1. This next digit is 1. 1 times 2 raised to power 0. Or, to make it easier, you can do this. You write each of these digits here. 1 0 1 1. 1 0 1 1 times this base times 2 plus times 2 plus times 2 plus times 2. That's the last one. No need to add plus. No need to write this plus because it's the last digit in 1. So next thing, you number the 2 that you have here. 0 1 2 3. Or you can do it this way. I'm trying to show you ways to recollect this. You can do it. Say one. You can write 1 times 2. 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. I haven't done that. You number the 2 0 1 2 3. Please take note you are numbering the 2, the number 2. So you then simplify. How do you simplify? 2 raised to power 3 is 8. Why is 2 raised to power 3 8? 2 raised to power 3 simply as 2 times 2 times 2. 2 times 2 times 2, which is what? 2 times 2, 4, 4 times 2, 8. So plus 0 times 2 raised to power 2 is same thing as 2 times 2, which is what? 4. 0 times 4 plus 1 times 2 plus 1 times 2 raised to power 1 is 2. That's why I left this 2 here. Can you see this 2? 2 raised to power 1 is 2. Then 1 times 2 raised to power 0 is what? 1. So 1 times 8 is 8. 0 times 4 is 0. 1 times 2 is what? 2 plus 1 times 1. Oh, plus 1 times 1. 1 times 1 is 1. No need to write that. No need to repeat that. 1 times 1 is what? 1. Because we are simplifying. So you have 8 plus 0, 8 plus 2, 10 plus 1, 11. 11 in base 10. So it means that 1011 is 11 in base 10. 1011 in base 2 is 11 in base 10. 1011 in base 2 is 11 in base 10. 1011 in base 2 is 11 in base 10. Let me do that properly. 1011 in base 2 is 11 in base 10. So, did you get that? Let me give you one final example on conversion from binary numbers to binary numbers. Final example. Let's take a bigger number. Example 3, 11111 in base 2. You want to convert to a number in base 10. So the same thing, the same concept, you can number the 0, 1, 2, 3, 4, 5. Are you saying that? So you can do this 1 times 2. Since they are 1 times 2 plus 1 times 2 plus this 1 times 2. The fourth one plus 1 times 2. The fifth one plus 1 times 2 plus 1 times 2. So you can number the 2's 0, 1, 2, 3, 4, 5. I think I skipped 1. Did I? Okay, I did not skip it because 0, 1, 2, yeah, I didn't. So 1 times, what is 2 raised to power 5? 2 in 5 places multiplied. 2 in 5 places, 1, 2, 3, 4, 5, then you multiply it. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So you have 1 times 32 plus, don't forget what we are doing, we're converting from base 2 to base 10. Plus 1 times 2 raised to power 4 is 2 raised to power 4, 2 in 4 places, you multiply. 4 times 2 times 2, 4, 4 times 2, 8 times 2, 16. So you have 1 times 16 plus, we've done 2 raised to power 3 earlier. So 2 raised to power 3, if you remember, is 8. 1 times 8 plus 2 raised to power 2, we've also done it earlier. 2 raised to power 2 is what? 4. And we've also done 2 raised to power 1 earlier. 1 times 2 raised to power 1 is 2. 1 times 2 raised to power 0 is 1. If there's anything you don't understand, you can watch the last 2 examples and come back to this, or you can rewind the video, you can slow it down. So 1 times 2 is 32. 1 times 6 is 16. 1 times 8 is 8. 1 times 4 is 4. 1 times 2 is 2. 1 times 1 is 1. So this will be 32 plus 16. That should be 48. 48 plus 8, 56. Plus 4, 60. 62, 63. So this is 63 in base 10. It means this number 11111 in base 2 is 63. So let me cross check my addition. 32 plus 16, that should be 48. 48 plus 8, 56. 60, 62. Or you can start from this 1 plus 2, 3, 7, 15. 15 plus 16, that's 31. 31 plus the 63. So that's it. So this is how to convert from base 2 to base 10, from a binary number to a denary number. Now, how about, you can go through that, you can rewind that and check. How about converting from base 10 to base 2? From base 10 to base 2. How about this? Moving from base 10 to base 2. We just move from base 2 to base 10, and I want to move from base 10 to base 2. So for a number to be in base 10, you can have this. Let's say you have 50 in base 10. You want to convert it to a number in base 2. 50 in base 10. You want to convert it to a number in base 2. Let me give you 122 and 1 7 okay, let's leave it as 178. So they're all in base 10. If I don't write this base 10, you should know that it's in base 10 from what I said earlier. So 50, if you want to convert a number from base 10 to base 2, you're going to be dividing by 2. You divide by the base. In fact, to convert a number from base 10 to another base, you keep dividing by the base till you arrive at a certain number, which I will show you. And don't forget, in converting from base 10 to base 2, the remainders are very, very important. You can do this. You can do this. You can write the remainder. The remainder is very, very important. Let me write the remainder here. The remainder is very, very important. The remainder is very, very important. 50 divided by 2, 25, remainder 0. 25 remainder 0. 25 divided, I believe you are in JSS3, you can divide 50 by 2. 25 divided by 2 is 12, remainder 1. The remainders are very, very important. Please take note. 12 divided by 2. You see that I'm dividing by 2 repeatedly. 12 divided by 2 is 6, remainder 0. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder what? 0. You keep on dividing by 0 till you get to this position. Now, you will not stop when you get to 1. You will divide till you get to 0. Now, we can still divide 1 by 2. But if we divide 1 by 2, we have what? 0, remainder. This is what? 1, because 1 is less than 2. 1 divided by 2 is what? 0, remainder what? 1. 0, remainder. This one, meaning it cannot divide it. But we have this one remaining. It cannot divide without a decimal point. I think I can put that way. 2 cannot divide 1 exactly. So it's 0, remainder this one here. So you are going to, oh, did I put R here? Sorry. I thought I wrote 1. So 1 divided by 2 is 0, remainder what? 1. So you are going to divide here until you get what? 0. You divide until you get what? 0. Now, having done that, it therefore means that 50 in base 10 is, now how do you write this number? You begin from bottom and you move up. From bottom up. Please take note of that. These things you need to take note of. If you want to convert from base 10 to base 2 or any other base, you divide repeatedly by the base you are going into, you are converting into. So 50 divided by 2, 25 remainder 0. 25 divided by 2, 12 remainder 1, and so on and so forth. Now, you do not get confused. When you get here, 3 divided by 2 is 1, remainder 0. But we won't stop here. We must arrive at 0 here when we've divided this. So to arrive at 0, you say 1 divided by 2 is 0, remainder this what? 1 here. So that I have 1 here. So you move from bottom up. How do you move from bottom up? You start writing these numbers from the 1 at the bottom. The next from it, 0, 0, 1, 0 in base 2. So 50 in base 10 is 1, 0, 0, 0, 1, 0 in base 2. 50 in base 10 is 1, 0, 0, 1, 0 in base 2. So let me do this second one. This is the first. So you have 1, 2, 2, 1, 2, 2. Don't forget the remainder is key. The remainder is what? Key. The remainder is what? Key. You don't necessarily have to draw this box, but I'm just doing that to separate the remainder from what I'm dividing, what I'm getting. 1, 2, 2 divided by 2. 1 divided by 2 is okay. is impossible, like we say. You say 12 divided by 2 is 6, 61. 2 divided by 2, 1. 61 remainder 0. 61 remainder 0. And you go to 61 divided by 2, 30 remainder 1. 30 divided by 2, 15 remainder 0. 15 divided by 2, 7 remainder 1. 7 divided by 2, 3 remainder 1. 3 divided by 2, 1 remainder 1. 1, you won't stop here 1, you must have a 0 here. So 1 divided by 2, remember I said the 0 remainder, this 1 what here. So since you've gotten 0 here, you can stop. Don't forget how I said you should write the numbers. You move from down up. So how do you move from down up? You say 1, 2, 2 in base 10 is, begin from this 1, 1, 1, 1, 1, 2, 3. For make sure you write the accurate amount of numbers, accurate amount of ones there. Make sure you do not miss any number because it will affect your answer. 1, 1, 1, 1, 0, 1, 0 in base. Oh, sorry about that. In base what? 2. 1, 1, 1, 1, 0, 1, 0 in base 2. 1, 1, 1, 1, 0, 1, 0 in base 2. In base 2. 1, 1, 1, 1, 0, 1, 0 in base 2. Let me confirm this. My division divided by 2, 61 remainder 0, yes. 61 divided by 2, 30 remainder 0, yeah. 30 divided by 2, 15 remainder 0, yeah. 15 divided by 2, 7 remainder 1, yeah. 7 divided by 2, 3 remainder 1, yeah. 3 divided by 2, 1 remainder 1, yeah. 1 yes, 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 correct. It's correct, it's correct, it's correct. Now, let me make this an even number. Let me make this an even number. 173. Is it possible? Is it possible to convert an even number to a number in base? Oh, did I call that an even number? An odd number, sorry, because these two are even. I'm very, very sorry. An odd number. These two are even. I want to use an odd number. What do I mean by an odd number? An odd number is a number that cannot be divided by 2. It cannot be divided by 2, meaning that once it's divided by 2, there will be a remainder. While even number can be divided by 2. So let me see, is it possible to convert an odd number from base 10 to base 2? Let's try and see. So the third one, we have 173. The remainder will be here. 173 divided by 2. You have 17 divided by 2 is 8. 16, 1. 86 remainder 1. Yeah, 86 remainder 1. It's now even. 86 divided by 2. 43 remainder 0. 43 divided by 2. 21 remainder 1. 10 remainder 1. Oh, 10 remainder 1. 10 divided by 2, 5 remainder 0. 5 divided by 2, 2 remainder 1. 2 divided by 2, 1 remainder 0. I have 1 here. I must get 0 here. So 1 divided by 2 is what? 0 remainder 1. So let me go over that division again. 173 divided by 2 is 86 remainder 1. Yeah. 86, that's 172. Yeah, 172. 86 divided by 2, 43 remainder 0. Yeah. 43 divided by 2, 21 remainder 1. Yeah. 21 divided by 2, 10 remainder 1. 10 divided by 2, 5 remainder 0. 5 divided by 2, 2 remainder 1. 2 divided by 2, 1 remainder 0. 1 divided by 2, 0 remainder 1. So it means that 173 in base 10. Don't forget we're moving from bottom to the top. 1, 0, 1, 0, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1 in base 2. If you notice, the numbers we are getting in base 2 contain just 0 and 1, because in base 2 you have 2 digits, 0 and 1. So that's how to convert from base 10 to base 2. So if there's any question, you ask me when we meet in the one-on-one sessions. Now do this. Let me give you something to do. Just 5 questions. Those 5 questions. Convert from base 10 to base 2. Let me change this to 44. Let me change this to 101. Let me see how well you can divide 101. Then let me make this even. Let me make this something 17 in this 10. Then convert this to convert from base 2 to base 10. So convert this one from base 2 to base 10. The first 10110, the second 10001. 1001. So do this 5 and I will see you in the next one. Bye.